We can differentiate a lot of functions now without having to use the limit definition, but we haven't thought about trig functions yet. For example, what is the derivative of sine of x? Well, here's a picture of the graph of the sine of x. We could approximate the derivative just by thinking about the tangent line to sine of x and seeing what it looks like. So at x equals 0, the tangent line looks like this. So that slope is kind of medium and positive, I guess. It's hard to know exactly what the slope of this line is, but I don't know. It's positive. So let's say it's, I don't know, 1. This is kind of a guess, right? We're really not sure exactly what the slope is. Now, by the time we get over to pi over 2, the tangent line here is definitely horizontal. So the slope is 0, and so the derivative is 0, right there. Now, when we get over to pi, the tangent line there, well, it's going down just as much as the tangent line as 0 was going up. So that means if we guessed 1 for the value of the derivative at x equals 0, then at x equals pi, I guess we should be guessing that the derivative is minus 1. When we get over to 3 pi over 2, the tangent line is horizontal again. And then when we get to 2 pi, well, sine is periodic with period 2 pi, so if the slope over here at x equals 0 we guessed is 1, then we should guess the same thing over at 2 pi, since this is the start of a new period, so 1 again. And if we sort of connect all these up, it's hard to know exactly how to connect these up. We could get a better idea of what the derivative looked like if we just accurately approximated slopes for more x values in between the few that we have here. If we did that, what we would find is something like this. And since sine is periodic, its derivative also has to be periodic, and so it's going to look something like this. Well, this graph should look very familiar, right? This looks a lot like cosine. So I guess what we're guessing here is that maybe the derivative of sine is just cosine. Possibly with some constant multiple out here, right? Because we sort of guessed that this slope was 1, but if it's a little bit bigger or a little bit smaller, the general shape of this derivative graph would change, but it would be a little shorter or a little taller, just kind of depending. So we think that the derivative of sine, it's something like cosine. Well, that's a decent guess, right? It's good to know what you think the derivative is before you try to calculate it exactly. But this isn't a proof. This doesn't get us out of actually finding the derivative of sine exactly. So let's use the limit definition to find the derivative of sine. So the derivative of sine at x, this is going to be the limit as h goes to 0 of sine of x plus h minus sine of x over h. So, right, as usual, I mean, as always, with a limit coming from a derivative, we get 0 over 0 if we just try to plug in h equals 0. So what can we do? I mean, it seems like there's really only one option. And that option is, right, the only piece of this expression that really has anything interesting happening is there's a sign with a sum inside. And we have an identity that we could use for that, right? We have a sum identity for sine. The sine of x plus h is sine of x times cosine of h minus cosine of x times sine of h. And then there's the minus sine of x from the beginning, right, from up here. Okay. So this might look worse at first, but it does have the advantage of each time a trig function shows up, there's only one variable inside of it instead of two. So now maybe what we could do is start grouping things, because we have two pieces that have sine of x here, and we have only one piece that has cosine of x. So let's group the pieces that have sine of x. So limit as h goes to 0. Let's see, the pieces with sine of x are sine of x times cosine h and minus sine of x. And then let's put all of those over one copy of h. And then also we have cosine of x times sine of h over h. So let's take the limit of this piece as well as h goes to 0. Well, for each of these individual pieces, we can actually separate the x's from the h's, right? In this first one, we can factor out this sine of x. So this is sine of x times cosine h minus cosine h minus 1 over h. And for the second piece, we get the limit as h goes to 0 of cosine of x times sine of h over h. But we're taking a limit as h goes to 0. So when we look at these expressions, x is acting like a constant as far as the limit is concerned. So we can actually move this sine of x outside the limit because the limit thinks it's a constant. So that gives us sine of x times the limit as h goes to 0 of cosine h minus 1 over h plus, and then same thing for cosine x here. We can move that outside the limit. Cosine of x times the limit as h goes to 0 of sine of h over h. All right, so we've reduced the problem of finding the derivative of sine of x to just finding these two limits. And it's a little bit hard to know how to proceed on finding these two limits. What I'm going to do is we'll graph these two just to see what they might look like, and then in a different video we'll sort of really prove that the value of these limits are what we think they are. So first let's graph cosine of h. So I'm going to have to use x for my variable to make GeoGebra happy. So cosine x minus 1 over x. Okay, looks like this. And you can see if we zoom in near 0 here, it looks like this function is going to 0. So that means that this limit is 0, we think. In fact it is, but we haven't really proved it. I'll prove it in a different video. And then over here, multiplying cosine x is the limit of sine of h over h. So let's graph sine of x over x. And it looks like the limit there is 1. So we think that this one is 1. And in fact it is, but again, I'll prove it later. So putting this all together, what we get for our final result is just cosine. So again, we started with derivative of sine of x, and what we got is cosine of x. So the derivative of sine is what we thought it was going to be, so that's good. While we're at it, let's find the derivative of cosine. So the derivative of cosine is the limit as h goes to 0 of cosine x plus h minus cosine of x over h. Well, if we used the sum formula for sine before, let's use the sum formula for cosine here. That's cosine of x times cosine of h minus sine of x sine of h, and then the cosine of x that was here to begin with, all over h. And you can see we're going to be playing the same kind of grouping game, except we're going to be grouping things a little differently. So this time this cosine x cosine h piece is going to go with that cosine. So limit as h goes to 0. So from these two pieces we can factor out a cosine x and that leaves cosine h minus 1 over h, and then minus, now we need this piece, minus limit as h goes to 0 of sine of x times sine of h over h. Now you can see we're getting exactly the same two limits as we did before, but the stuff around them is a little bit different. So this time it's the cosine of x part that gets multiplied by 0, and then it's the sine of x that gets this one that's multiplied, whose limit is 1. And so this time it's the sine that survives and instead of the cosine. So we get, and also there's a minus sign there. So the derivative of cosine is, it's not sine, it's negative sine. And that actually makes sense if you look at a graph. Right? Cosine looks like this. And if you think about slopes of tangent lines, at x equals 0 here, the slope of the tangent line is 0, so our derivative should start at 0. At this spot right here, this is pi over 2, the slope of the tangent line is negative. Seems like it's maybe about negative 1, so like this. I guess, sorry, it should be more like this. Here, the slope of the tangent line is 0 again. Here, the slope of the tangent line is positive. As positive as the last one was negative, so maybe positive 1. And then, once it gets to the top here, it'll be flat again, so like that. And joining these up, you can see that this isn't a sine curve because it's starting going down, but other than going down instead of going up, it looks exactly like a sine curve, so that means it's just negative sine. So this, certainly from the graph, this seems very plausible. So now we have a derivative for sine and cosine. The derivative of sine is cosine, and the derivative of cosine is negative sine. In fact, this sort of keeps going. There's kind of a 4-step cycle here. If you start with sine and you take one derivative, you get cosine. If you take a second derivative, you get negative sine. If you take that and do another derivative, well, now you can move the minus sign outside of the derivative and take the derivative of sine, which we know is cosine. So the third derivative gave us minus cosine. And then if you do yet one more derivative of minus cosine, well, now you can move the minus sign outside and you get the negative of the derivative of cosine, so that's the negative of negative sine, and that's positive sine. And then you're kind of back where you started. So the derivatives of sine and cosine sort of have this cycle that's 4 derivatives long.